No matter how luxurious the car you drive, its initial form is just a pile of metal coils like this. So how exactly does it transform into a complete vehicle? Let's take a look. First, industrial robots feed heavy aluminum coils into the forming station. Then, a 5,000-ton press begins its work, precisely shaping the sheet metal into a preset geometric form, step by step carving out the contours of the body panels. This massive production line must complete the manufacturing of all metal parts for the car, whether it's the hood, trunk, mainframe, or delicate components like rear-view mirrors and car doors. The entire car body is assembled from about 500 different parts, firmly connected by nearly 2,000 weld points. Once the car body assembly is complete, it will then enter the paint shop. This painting step begins with the primer application. The primer's role is crucial. First, it levels the surface. Second, it resists UV rays, corrosion, and extreme temperature differences. Third, it provides a better adhesive base for the subsequent top coat. Initially, the painting robot will evenly apply 5 layers of coating onto the car body. A single car like this will require about 45 kilograms of paint. To ensure uniform paint film thickness, we use electrostatic spraying. For example, when painting car doors, they're suspended on a conveyor and charged. The atomized mist in the air carries an opposite charge, attracted like a magnet to the metal, ensuring a more even paint film across every inch. Once the primer and top coat are complete, the car body is sent for fine polishing and grinding. The next stop is the polishing room, which is the core of quality inspection. Under strong light, the technician will polish the car body to a perfect mirror finish. After painting, it will enter the final assembly workshop. At this stage, car doors are usually left off, mainly for workers to easily operate inside. Meanwhile, the interior is also being prepared. Take leather seats. The entire hide is first inspected. Then a laser precisely projects the cutting shape, maximizing material use like a puzzle. Robots then cut it, followed by the crucial wrapping stage. We'll first vacuum pack the foam pad to temporarily shrink it, so we can smoothly fit the leather cover. Then it expands back, making the surface smooth and plump. Finally, the finished cushion and backrest are assembled, ready for vehicle installation. This logic also applies to other soft padded components inside the car. Now, returning to body assembly, the next step is to install the car's engine. The car body is first lifted to the correct height. Then a small manually operated platform lifts the engine into place below the engine bay. The engine is connected to the body via a dedicated subframe and features small, elastic vibration damping mounts to isolate engine vibrations and prevent them from transferring to the entire vehicle. When an engine runs, dozens of micro-combustions happen inside each second. The fuel air mix enters the cylinder via the intake valve. The spark plug arcs, igniting it. The released energy pushes the piston down, rotating the crankshaft. The piston then returns to top dead center. Exhaust gas is expelled through the exhaust valve, entering the exhaust system. Next, we install the gearbox. Its interior consists of an input shaft, an output shaft, and multiple sets of gears with different ratios, and it connects to the engine via clutch plates. Its operating logic is quite simple. When you press the clutch pedal, the clutch disengages, the gearbox temporarily disconnects power. At this point, you can shift from first gear to second and complete the gear changes sequentially. Then the two shafts move relative to each other, and power is sequentially transmitted through gear sets of varying ratios, ultimately passing from one shaft to another. When you release the pedal, the clutch re-engages and the engine and transmission reconnect. Now in a new gear, this will correspondingly output more or less RPM and torque. For example, here is a rear-wheel drive layout, so a drive shaft and differential need to be connected to the rear of the transmission. The differential is located in the center of the rear axle, distributing the drive shaft's rotation to the left and right half shafts to drive the car's rear wheels. Next, we begin installing the car's suspension. The suspension connects the wheels to the body. Its core components include the drive shaft, which transmits power to the wheels, the steering knuckle, which changes wheel direction based on the steering angle, and the shock absorbers responsible for absorbing bumps. After that, we'll continue to assemble the brake discs and wheels. As the vehicle moves, the brake discs rotate in sync with the wheels. When you press the brake pedal, brake fluid pushes the pistons and the brake pads clamp the discs. The friction slows the wheels, bringing the vehicle to a stop. Due to continuous friction between the pads and the disc surface, the brake discs heat up rapidly, sometimes even glowing red. Next, we'll install the exhaust system. The several extended pipes on the engine make up the exhaust manifold. It collects exhaust gas from each cylinder into the main exhaust pipe. To reduce noise, we will install a muffler. Mufflers typically have multiple chambers. As exhaust gas flows through them, its speed is reduced, effectively controlling noise. Finally, there's the tailpipe, where exhaust gas exits the vehicle. Now, let's lower the vehicle. First, we'll install the air filter under the hood. It's responsible for filtering out impurities before air enters the cylinders. Meanwhile, install the generator. The engine not only drives the wheels, but it also powers the generator, supplying all the electricity for the entire vehicle. Then, install the fuel filter, regulator, and fuel pressure sensor, making sure the fuel delivered to the engine is both clean and consistently regulated. The battery stores energy charged by the generator and provides high current for starting. When our car battery dies, we can use jumper cables to connect it to another car. First, we borrow the other car's battery to get our engine started. Once the engine is running, the alternator will take over and charge our battery. Behind the front grille is the engine's cooling radiator. Its operation is similar to an air conditioner. Coolant draws heat from the engine and evaporates into a gas, then enters the radiator. As you drive, the oncoming airflow passes through the radiator, cooling the vapor.
Liquid return. Another set of key components is electrical: relays, fuses, and circuit breakers. They are like the neural network of the entire vehicle's electrical system. Wiring harnesses extend from here throughout the vehicle. Next, dozens of accessories are added, like brake fluid and wipers. Then, interior modules are fitted, starting with the dashboard and center console, followed by the front and rear seats, and finally, the steering wheel and airbag module. All the electronics must connect to the main electricals and wiring harness under the hood, and the audio system, of course, also needs to be in place. Next, the front and rear windshields are installed. Then we move to the trim, like the gear shift panel and decorative strips. At this point, the car doors can be reinstalled onto the body, and the entire vehicle is basically formed. However, it still needs to undergo several tests. The vehicle will be inspected again under strong light to find any minor scratches that might have been left during assembly. Then it enters the rain chamber, simulating heavy downpours. Technicians inside check for good sealing and no leaks. Next, the car is placed on the generator-driven test bench, simulating real road conditions. It completes acceleration and braking tests to assess mechanical performance and verify accurate brake response. Once all the necessary tests have been passed, this vehicle will be considered officially complete. It will then be transported by ship or a large truck, heading directly to the dealership's showroom.